So alright, let's use the elimination method now. So in the question, to use the elimination method, we have 2x plus 3y equals 13. So we have 3x plus 2y equals 17. So using the elimination, we actually find a variable to eliminate. Either you choose to eliminate x or you can choose to eliminate y. Let's choose to eliminate x. So if we choose to eliminate x, I will say equation 1, which is the first equation, times the variable of x here, which is 3, and that's the equation 2, times the variable of x here in equation 1, which is 2. So that means I will multiply all of equation 1 with 3, so that I can achieve my aim. So all of equation 1 times 3. So 3 times 2, that is 6x. 3 times 3y, that is 9y. 3 times 13 is 39. So 2 times 6x is actually, 2 times 3x is 2, 6x. 2 times 2y is 4y. 2 times 32 is 64. Then let us solve. If we add, we will not eliminate y. So we have to subtract. The aim of multiplying this 3 with equation 1 and this 2 with equation 2 is to get the same coefficient in our x and y, which is this. Next now is not to decide whether we need to add to eliminate x or we need to subtract. So eliminate x, we need to subtract. If we add, x will not be eliminated. Let us subtract. So 6 minus 6 is 0. 9y minus 4y is 5y. 39 minus 64 will give us minus 25. Divide this by 5, y will be equals to minus 5. So to now get x, we take end of the equation. Let's take the first one. So from 2x plus 3y equals to 13. So we have 2x plus 3, y is minus 5 equals to 13. So we have 2x plus 2x, 3 times minus 5 is minus 15 equals to 13. So we have 2x equals to 13 plus 15. So we have 2x equals to 28. So x is equals to 13. Alright, so that is that using the elimination method. Easy and faster. So now the graphical method. So if you have to use the graphical method, I think I taught us how to draw a line earlier. So I explained to draw a line, you need to get the intercept. So this is done already. So let's wrap it up. Alright. So now to solve using the graphical method, so we have 2x actually plus 3y equals 13. So we have 3x plus 2y equals 32. So we need to get the intercept. So we say equation. So then we say x value when y is 0 and y value when x is 0. So let us obtain that. So here is 2x plus 3y equals 13. So when y is 0, 3 times 0 is 0. So 2x equals 13, we have 7.5. So when x is 0, 2 times 0 is 0, 13 divided by 3, that will give us 4.3. So let's do that of the second equation, 3x plus 2y equals 32. So when y is 0, 2 times 0 is 0. That is 3x equals 32. That will be 32 divided by 3. That will be 10 minus 6, 7. If I may be right. So for the other one, when x is 0, 3 times 0 is 0, that will be 16. So 2y equals 22, so that will be 16. So we've obtained the intercept. This is the intercept we are now going to use to draw the line. So we draw each of the line. So x value there is 10.6. Y value there is actually 16. Highest value. So I think I need to have high value of x here. X at the right one. I need to shift this line. And I need to move it down because I don't have any negative value for y. So it's only positive for x and y. In fact, I'm able to ignore the negative since I don't have negative value. So I can indicate the flows in the graph. So So I have 0 here. Since I don't have negative, I have not negative. So I can use, what scale should I use for the centimeter? This guy is how the length of the centimeter is. Maximum value for S is 10.5. Let us just use 2 and save ourselves some stress. 10 and 12. So for Y is 16. Let's use 2 as well. I hope I'm able to stay true up to 16. So we have 2, 4, 6, 8, 10, 12, 13. Let me scale it up to 16. So for the first one, when Y is 7.5, when X is 7.5, this X value 7.5, because it's 7.5 in the 7 is here. Yeah. If 7 is here, 7.5 is here. So we need here. So look at that, I'm sketching it. So 4.333. So Y is 4.333. So 4 is there. If 4 is there, so 5 is there. Then 5 is there. Let 4.33 is there. So we can actually divide it together. So that is the first one. You should use a good ruler. So it's not straightforward, it's not straight enough. Now for the second line, Y is X is 10.67. 10.11 will be here. So 10.67 is there. So that of our Y is actually 16. Our Y is 16. Which means interesting. We have to meet. X is 7.5. 7.5 is here. My Y is 4.33. Am I right? It's here. So Y is 10.67. It's here. My Y is 16. Yeah. So it's okay. Let's draw it. So there's a visit. So we have to now keep drawing until the limit. Then we keep drawing it. So we can draw it. So where we get it? So that means negatives is still needed. So negative will run for is actually still needed. So draw the negative. So what it then is, you can say that meet at around here, at X value here, and at Y value here. So if you look at it very well, Y will specialize in -5 over 10, -5 here, and X is specialized in what? What you do obtain, I said that when it solves. I think our X was actually I know -5 is Y. Yeah. Our X is actually what the do of 10. So if Y is -5, I will say -5 times this, so -1. So our X is going to be -1. I think that's what we're doing. Our X is going to be -1. It's not -1. So -10. Okay. 14. So our X will be 14. So it's very close to 14. But it's not straight. -5 and 14. So if you look at this graph now, you can see that our S is around 14. As well as we obtained correctly, Y is -5. So that is just the point of that. If we use a very good graph and our hands is straight, we obtain that perfectly. So that's how to use graph to solve it. So, alright guys, so next thing we'll be moving on to, after we have solved the equation using both methods. So the solution is as follows, as you can see. So this is the solution obtained. So using both methods, so we actually obtained it. So that is the substitution as obtained. So you can also try some of the other examples. So by elimination, so this is elimination method using another example. And this graphical method using another example. So you can also practice just the way I taught you. You can practice. So next thing now we have to look at now is quadratic equations. So we'll say quadratic equations is any equation which is of this form. Any equation that is of this form, as we have said earlier, if the equation is actually of the form, any equation that is actually of the form ax squared plus bx plus c equals to 0 is a quadratic equation. And to solve this type of equation, you can use factorization method. Is that okay? You can use continuity square method. So we can use formula method. So we can use graphical method. But we're not going to be doing everything. So what should be hand in hand for you in exam is factorization, if you remember any factors and formula. We will forget about them as far as I can examine. Please consider. You can't be restricted to the use of any method in the exam. So if you are given any question in the exam, think of using factorization. And if you cannot get the variable of factorization, go to what? Go to the use of formula. So for the factorization method, it just involves you factorizing the variable. Think of two factors. Is that okay? I will tell you the rate of factorizing. So just for you to multiply a and c together. So upon multiplying ac, you now think of another factor of that ac, or you can be the same what you can be what you have used before, or it will be a different factor. So you think of that factor of ac that will be summed to give us b. You will use those two factors to replace b, x, and you are good. But in formula, our x now, to solve for x, is to use this formula, the value formula, which is called Almighty formula, over 2a. So that will be minus b plus or minus b squared minus 4ac over 2a. You will obtain your x using the formula. So that is how we use it out to work with two methods. So let's take an example. Let's see whether we can actually pick an example together. So here we have an example here that says solve the following quadratic equation by factorization method by formula and by graphic. We're not using graphic. The first one by factorization method. So we actually have we have x squared plus 6x plus 8 equals to 0. So I will just say x times 1, a is 1. So c is 8. 8 times 1 is 8. What are the two factors of 8 that we sum to give us 6? Two factors of 8 might be 4 and 2. Is that okay? 4 times 2 is what? Is 8. So, and 4 and 2, since we have positive 8, when we multiply 8 and 1, is positive 8, and 8 squared. Now, the two factors can either be negative or positive. So, that means it has to be positive. Because like, the sum, we have to sum is 6 and x, and 6 there, we have a positive 6. So the two factors are 4 and 2. But the two factors can either be 4 and plus 4 and plus 2, or minus 4 and minus 2. Minus 4 times minus 2 is 8, it's correct. But if we sum minus 4 and minus 2, it gives us 6. And it's plus 6 we have here. So we are using plus 4 and plus 2. So that means we will say x squared plus 4x, which is the first factor, plus 2x, which is the second, will replace 6x. Or you can say plus 2x plus 4x will replace 6x. So that is plus 8 equals to 0. We will now group the first one and group the second one equals to 0. So what's common here? X is common. S plus 4. So what is common here? 2 is common. S plus 4 as well. So we have two expressions. What is common here? S plus 4 is common. And what is common here? What is left after that factorization? We have S plus 2 left equals to 0. Now, since this and this is 0, that means either S plus 4 is equal to 0 or S plus 2 is 0. Therefore, either both of them are equal to 0 or 1 is equal to 0. So we are assuming both is equal to 0. So therefore, x will be equal to minus 4 or That is the solution for the first one. Yes, if we solve using factorization of method. Now the second one, we actually have to use formula. So using our formula method, the second question. And what is the second question? The second question is 2s squared plus 13x minus 16 equal to 0. So compare, our A is 2, B is 13, C is minus 16. So therefore we can obtain x to be equal to minus b plus or minus b squared minus 4x over 2. So we have x to be equal to minus 13 plus or minus b is 13 squared minus 4 times a is 2 and c is 16 all over 2 times a is 2. All I'm not too fast. I'm going to substitute the values into it. I'm going to obtain our x. But that formula can be used for anyone. But it's not all that equation that have two factors to look for. So yes, it's not all. So that's why complexity will come. Like for the second one we are solving now, I don't think 2 times minus 16 is minus 32. There is no such factor of minus 32 are going to solve that will give us 13. We don't have. So the second one is not factorizable. So I'm very sure. So that is why the equation will help us out. So the other formula will help us out. So we have x to be equal to minus 13 plus or minus. So here we have 169. So minus, what is 4 times 2 times 16? Let me do my calculator out. So 4 times 2 times 16 give us 128 over 4. So we have x is equal to, so 169 minus 128, so we have minus 13 plus or minus square root of 41 over 4. So our x will be equal to minus 13 plus or minus square root of 41 gives us 6.4 over 4. So our answer will now be x will be equal to minus 13 plus 6.4 over 4 or minus 13 minus 6.4 over 4. So either of the two. For the first one, let me finish it up. Minus 13 plus 6.4 divided by 4 gives minus 1.6. Right for the first answer. So our x is minus 1.6 times, or for the second one, minus 13 minus 6.4 divided by 4, we have minus 4.85. So these are the two value for x. And I've told you that we are not solving the problem using value. So if you are giving an exam, just be rest assured, use that common factorization of formula with method. So that is just the explanation there. So for the next thing on board now to do, and to talk about, let me look at next thing we look at is that is what we did. The second one we already did. Yeah. Telling you I made a mistake. 6 minus 16, I used 16. So minus 16. So here should be minus 4 plus 4, that will plus 128. A very big one for me. So 128, 169 plus 128. Yeah, that will be 297. So here is not possible, it's 297. So what is square root of 297? A very big one. That is 17.23. 17.23. So and here we have 7 plus 70.23 minus 70.23. So if we now say minus 13 plus 17.23 divided by 4, we actually obtain 1.06. So 1.06 in positive, not negative. And for the second one, minus 13 minus 17.23 divided by 4, we obtain minus 7 minus 7.56. So that is the correct answer. So we just obtain the correct one. And that should be similar to this.
That is a huge mistake for me. So sorry about that. So that will be the same with last name. So we have simple. So we have that now. This graphical method, like where I taught you in graph, you can as well do it. I've explained the graph of quadratic equation earlier. So you will graph the equation normally and obtain y value. So this is the graph. So where the graph touches the x-axis is the solution. That will be here. That will be minus 4 point something, almost 4.5, and here 1 point something, 1.5 stop or 1.6. So that is just the answer. So inequalities and their graphical solutions. So inequalities are opposite of equations. As far as inequalities are concerned, so we are actually dealing with some kind of expressions that of non-balance, that are not equal. So in inequalities, we have different inequality signs, like equality that is just one sign. Equality is balance. So if something is not balanced, it's to different edges. You can have less than. So when we have the hand like this, it is less than. So this sign you can see is less than or equals to, as you can see on the board. So for the second one is greater than or equals to. These are the for this sign. These are examples. Everybody knows that 19 is less than 30. 2x plus 5 is greater than. Okay, this is another example here. Depending on what value for x is, that will be greater than that. So, and we have 3x plus 2y is 6. We have rules of inequality. I think I've explained that in the introductory video of business mathematics. I said if you add or subtract same value from both sides of inequality signs will remain the same. If you multiply by a positive value or you divide by a positive value, the inequality sign will remain the same. But if you now if you multiply by a negative or divide by a negative value, the inequality sign will change. You don't forget the rule. Yes, negative value will change the inequality sign. So that is just the basic rule of inequality. So here it says, indicate the region where each of the following inequalities is satisfied. So we'll quickly run through everything. So I think if we can run through, it will be good. So we will draw the graph, we'll use number line to illustrate and draw graph to illustrate. I think having a very good understanding of this area is very, very important. Why is it important? It's because of the fact that you will be required, or you will need this when we get to the linear program, which is an aspect of OR, operation research. You will actually need that a lot. So it is very important that you put that into consideration. So it's very important that you put that into consideration. So don't miss it up. So we have to indicate the region where each of the following inequalities is satisfied. So we'll take the first one. So the first one is actually for the first one, we have 2x plus x less than x plus 8. So we have to indicate the regions. So first, we need to solve for x first. So let's move x to the right side. The sign will change, have it? So by normal, the sign will be multiplied by negative. So we'll say 2x minus x less than 8. Move 5, that will be minus 5. We are still good. So we have x less than what? Less than 8. So if we draw this on a number line, you can just, since it's a single value x, and number line we have 1, 2, 3, 4, and so on. Minus 1, minus 2, minus 3, and so on. So as I'm going to the right, the value is increasing, and you're going to the left is increasing. These are negative numbers. You are not just drawing graph. This is just the graph, but I'm using just one value. So yes, you have x less than 3. So this is 3 here. Which value are less than 3? The left are less than 3. So we'll just do this. And all of these values are continuing like that to the left. You will share this part because you don't have, because 3 is not inclusive. I think we have less than equals to share this part. So it will not be shaded because we are saying the 3 is not what inclusive in the value. So that is that on what on A. A has been done. Now in B, we have 4x plus 7
greater than or equals to 2x plus 15. So we'll solve this now. So for the like terms, we have 4x, move 2x, that will be 2x greater than or equals to 15, move 7 minus 7. So we have 2x greater than or equals to 8. Our x will be greater than or equals to 4. So if we divide this out by 2, yes, I put the like times here, I move my 2x here, I move 7 to the last part of the equation, and there is 2x, and there is what is 8. I divide this out by 2, and I have x greater than what, greater than 4. So to draw this on a number line, we have so here is 0, so I have 1, I have 2, 3, 4, 5, and so on. So minus 1, so minus 2, minus 3, and so on. So I have 4. So value greater than 4 and to the right. So going straight like that, and I will shade it because 4 is included. Is that okay? So we shade it, 4 is included. So that is what that. We've done the second one. The third one now says, for the third one, we have on C. C now said we have 3x plus 10 less than or equals to 5x minus 2. So we got like times, is that okay? We have 3x, move 5 to this side, that will be minus 5x. Get that less than or equals to minus 2 minus 10. So we have, that will give us minus 2x less than or equals to minus 12. So we divide this side by minus 2. So we have minus 2x and minus 2. Since we are dividing by negative, what happens? The sign will change to greater than or equals to, the sign will change. I explained earlier in the rule. So minus 12 over minus 2. So we have our x to be greater than or equals to 6. The sign will change immediately. So that is our x. Now, find out the number line. What are we going to obtain? So if it is drawn on a number line, we actually obtain, so we have 0 here, so 1, 2, 3, 4, 5, 6. So here we have minus 1, minus 2, minus 3, minus 4, minus 5. So we can just stop. So 6 greater than 6. And it's included, so it's going to the right. All values to the right. 7, 8, 9, 10, and so on. To make it true. These are the true values. 6 is part of the true value, but 6 is included in the value. Inequality value may not have just this value, one big value. We have one, and it's another. So for us to like range of value by make it true. Range of true values for the word for the equation. That is all about the third one. Now for the fourth one, we have dx greater than 0. We are not solving anything. We are just asking the number. X greater than 0 and we explain here. Exactly. So we can just use both equations actually. So we can use both equations, both axes. So let's have a situation where we have both axes here. Yeah, that will make more easy for us. So let's find ourselves in the corner where we have both axes here. So here we have x greater than 0, greater than or equal to 0. So if we have both axes here, so those parts, these are things that is going to the right, it's increasing. So these are positive value for x. Positive value 1, 2, 3, 4. Negative value for x minus 1, minus 2, minus 3. Positive value for y, Negative value for y, minus 4. So we are asked to do this. Just say we are going what? When x is greater than 0. We are talking about this thing here. Everything here. To the right here. And here too. Everything here. These are the questions where y happens. So So that means to the right. I can also use just one array as we used earlier, and that will be the right thing from here to here. So I'm using both actually. So the shaded portion is here. For s is greater than equal to 0. So everything here to the right of what? Of the x-axis. These are the increasing or positive value for x. Now E now says return G. Let me rub that shaded portion up. So E now says we should actually obtain y greater than or equal to 0. So our portion of y greater than or equal to 0 is the up side, up. So all of this portion here, irrespective of y values. So all of this up side here are very positive towards y. These are positive value up, these are negative value. So if we say y is greater than or equal to 0, so we are picking it up from 0 up. Is that okay? Irrespective of x values. For x greater than 0 is on this place to the right. Negative on this side. So that is just the point there. So we need all of these things here in inequalities, like linear programming, so I find the visible region or shaded portion or the true values is out there for the inequalities. Now, next one now is now where x is greater than 0, y is greater than 0. So where x is greater than 0 at this, at where x is greater than 0, y is positive here, x is negative here. Sorry, at where x is greater than 0, y is positive here, y is negative here. So that means the portion whereby x and y will be negative, positive is this point here. So we are doing x greater than 0 to equal to 0. At this point when y is positive, s is negative here. So the way we are looking for is here. So, but at this point, y is negative, x is negative, y is positive, so it's out. Yeah, so because we are looking for both when both are positive. At this point, both are negative. At this point, x is positive but y is negative. So all of the three sides are left. So what we are dealing with is just this portion. So what we have to deal with is just this portion here. So sorry about the light. So it's just this portion here we have to deal with. All negative sides are left. So for the next one here is to say we have to obtain when x is greater than equal to 0, y is less than equal to 3. So this is what we do here. So the question was asking me why x is greater than equal to 0. So where x is greater than equal to 0, let me go back to my negative. So of x and y, these are negative here for y. These are negative for what? For x. So you are saying y is greater than equal to 0, x is greater than equal to 0, these are the question here, and y is less than 3. So y is less than 3, y is less than 3, and equal to 3. So this is where y is 3, and we trade it. So y is 3 here. But y, x is now positive, so we are only dealing with this side. We must not enter where x is negative. So we are not entering here at y equal to 3. Because if we enter here, x is negative here. So because we are saying that x must be greater than 0, so we are only dealing with this side of what? Of y, not this side. So because x will be negative here. So at this side now, y is 3, it's shaded already. So that means y is less than equal to 3. So we are looking at down. Because this is where y will be less than equal to 3 and 3 downward. Is that okay? But point whereby x will be positive is this right hand side here. So all y here are not true, all y down are true, all s here are not true, all s here are true. So we are looking for the shaded portion here. Sure. And then we are out the shade. So that is the shaded portion. I think it's very easy and straightforward. So now for the next one now, we have to shade 2x plus 2y less than equal to 6. X plus 2y less than equal to 6. So to do that, this is what we are going to do. That as well is simple and easy to do as well. So this is what we do. So here we have to obtain x plus 2y less than equal to 6. So I will have to get the points when x is 0, what is y? So if it's 0, our y will be equal to a. And what is x when y is equal to 0? So when y is equal to 0, what is 0? Our x will be 6. So can we now draw the line on the number line on the graph? So normally we go with no. So we have 0 here. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 1, minus 2, minus 3, minus 4. So x is up to 6. So 5, 6. Now the question is when y is 3 here, at where x is 0. So where is this? X is 6 at when y is 0. So x is 6. So we join the line together. A perfect straight line. I don't ask you to go, so still going. So the question answer, so this is the line here. The line x plus 2y less than equal to 6. So we have less than equal to 6. So all up and greater than, and all down and what are less than. So all of these are true value for that. Okay, so all of the downward of the line downward because we have less than. So all the downward of the line are true value. Upward and not true. So that is what I mean explain the value. That's how to locate the visible region. I hope that is very easy and straightforward to understand. So another thing now we need to do, another one here, is to consider. So another one we are given is we are given 3x plus 2y greater than or equals to 12. So we obtain that normally as we usually obtain when x is 0, what is our y? 3 times 0 is 0, that will be 6. So what is x when y is 0? So 0, that will be 4. So drawing that on the graph. So y is 6. So I can say I have 1, 2. I'm not using any scale. I'm believing that is 1 centimeter. 6. So minus 1, minus 2, minus 3, minus 4, and so on. So here is 1, 2, 3, 4, 5, 6, 7. So I have minus 1, minus 2, minus 3, minus 4, minus 5. So when x is 0, y is 6. So y is 6 here. When x is 0. So when x is 4, y is 0. So here, I will join together. So if I join together here, I will have this and this. So the person was not talking about greater than, so up. I'm looking at up. Up. So that is the visible region. So next time is this. So because even for it at 4, greater than. So the visible region is up. And that is very easy. I just hope you are getting that. So you can always replay the video to check if you are not getting the idea. Now, what if we now have two lines on the same number line? So actually the J gave us 2. Yeah, and we have to draw. So I will have to say, so to do the penultimate question, to answer the penultimate question, we have, let's just draw the box. So we have the equation. So the equation, the inequality, let's call it an inequality. So the inequalities. So the value for x when y is 0 as usual, the value for y when x is 0 as usual. So the first inequality is 2x plus 3y less than equals to 9. So at y is 0, 3 times y, 3 times 0 is 0, y is 0. Now we have 9 divided by 2, 4.5. And s 0, 2 times 0 is 0, so 9 divided by 3. So this is x intercept, this is y intercept for the first inequality. For the second one, so that we'll be able to draw the line. So we have when y is 0, so that will be 2 times 0 is 0, that will be 2, 10 divided by 5. When x is 0, 5 times 0 is 0, then 2 divided by 2, that will be 5. We have this already. So now, can we draw this on a number line? Yes, we can. So we have 0 here. So let's say we have 1, we have 2, 3, 4, 5. This is the flows. So we have the flow. Then we have 6. So we have 1, 2, 3, 4, 5, and 6. So we have minus 1, minus 2, minus 3, minus 4, minus 5. So where is minus 1, minus 2, minus 3, minus 5. So when y is 0, x is 4.5. So yeah, 4.5 is there. So let's just do that. Half between 4 and 5. So when x is 0, y is 3. So y is 3. So let's draw the first inequality line. So join them with a good ruler. And this is the first inequality line. What is the visible region of the line? This down. Now for the second line, we have when x is 2, when y is 0, x is 2, y is 0, so this is 0. And y is 5 when x is 0, y is 5 when x is 0. So we have this, join this together. So this is the second line. So now, where is now common? For the first line, the common region is this, actually downward. For the second one is this. If you look at it there, where is now common to both? I think where is common to both is this region downward. Any other region is not common. So yes, that's where it's common. If you pick from here, all here are common to this line, but it's not common to this one. If you pick here, all here are common to this line, but it's not common to this one. So where is not common and where are shaped? Because both of them are down. So this is where it's common to both. So you must choose what's common to both of them. Because we are drawing both lines on the same inequality. So I think this knowledge is very, very important for the understanding of what of linear programming. Now let's draw the last one. Last one there is just exactly like the linear programming. Yeah. So let's draw. So for the last one, we have 2x plus y less than or equals to 18. 1.5x plus 2y less than greater than or equals to 15. X is greater than or equal to 0, y greater than or equal to 0. So for this one there, x being greater than or equal to 0, y being greater than or equal to 0 means that we are only considering positive value for x and positive value for y. That is what we are only considering. We are not considering the negative value. So when we say the inequality given, so I will rub this off. The same with I2, so I will rub the graph that we have properly drawn before. So I will rub that off. So for the first equation, I have 2x plus y less than equals to 18. For the second, I have 1.5x plus 2y greater than equals to 15. Now when y is 0, what is x? So y is 0, gone. So I have 2x, 18, that will be 9. 18 divided by 2. So what is y when x is 0? So I have 2 times 0 is 0, so y is 18. Alright, when y is 0, 2 times 0 is 0. Give a value of 1.5, that is 10. You can check. So for the second one, when x is 0, what is y? 1.5 times 0 is 0. So we have 2y equal to 15, that is 1.5. 7.5 normally. So what is that? So now, since we now have the second equality, x is greater than equal to 0, y is greater than equal to 0, it is telling you only consider the positive value for x and y. So we'll have only this, and we have this and this, and this. So no negative value at all. So that is all. So I won't draw this one down to a negative. I won't draw this one here to a negative for x. No negative for y down, no negative for x. Because x is greater than equal to 0. So from 0 like this, positive only, y is greater than equal to 0. So this graph like this, I've answered these two inequalities. So let's draw this other inequality, the remaining two now. No, we have 4. So this one I've already on it. In linear programming, we call that non-negativity constraint. Is a constraint. So